Factor completely. I have 3x to the fifth minus 75x cubed. I'm going to look at the two numbers. I have 3 and negative 75. I'm going to look for the greatest common factor. So the greatest common factor between 3 and 75 would be 3. So I want to factor out the 3. If you look at the terms and the variable part, I have an x to the fifth, x to the third. So each term has at least 3 x's, so I'm going to take out an x to the third. So when you divide each term by the greatest common factor, you will end up with x squared minus 25. So you always take out the greatest common factor first, and then you need to see if you can factor any more. In parentheses, I have an x squared minus 25. That is a difference of squares. I can take the square root of x squared and get x, square root of 25 and get 5. So remember that if something is a difference of squares, it will factor to plus for one factor and minus for the other. So I'm going to put an x first, and then my 5, the other x, and then the 5. And don't forget to take your greatest common factor from the first step and bring it down as well. So we'll end up with 3x cubed times x plus 5 times x minus 5. And if you look at these factors, they can't be simplified anymore. So that is our final answer. Let's try one more. I have negative 16n squared plus 12n. I want to look for the greatest common factor. So if I look at negative 16 and 12, it looks like the largest number that divides into both of those would be 4. And we like the first term to be positive, so let's take out a negative 4. And if you look at the variable, each term has at least one n. So let's take out negative 4n, and let's see what we're left with. Negative 16 divided by negative 4 is positive 4. N squared divided by n is n. And then 12 divided by negative 4 is negative 3. N divided by n is positive 1. So if you look at this, we've got negative 4n, and then we'll have 4n minus 3. Neither one of those can be simplified any further, so this would be your final answer. So this is your factoring completely.